Okay, see this question number 22 from chapter number 5 of HC Verma. In a simple Atwood machine, two unequal masses M1 and M2 are connected by a string going over a clamped, light, smooth pulley. Two masses are there, M1 and M2, passing connected by a string passing over this pulley. In a typical arrangement, M1 is given 300 gram, M2 is given 600 gram. The system is released from rest. Find the distance traveled by the first block in the first 2 seconds. So this is your first block. So it's simple question. We have to find the accelerations and then solve the equations using equations of motion. So tension on M1 is upwards. Tension on M2 is also upwards. M1G is the force downwards. M2G is the force downwards. So M1 is heavier than, sorry, M1 is lighter than M2. So M2 will come down with acceleration A, M1 will go up with acceleration A. So we just write the equations for Newton's second law. For M1 block, T minus M1G equal to M1A. For M2 block, it is going downwards. So M2G minus T is equal to M2A. Now you add the two equations. So you get M2G minus M1G equal to M1A plus M2A. So A will come out to be equal to M2 minus M1 multiplied by G divided by M1 plus M2. Okay. So this is the acceleration of the blocks. Now let's just put the values. So M2 is 0.6 kilogram, M1 is 0.3 kilogram. So 0.6 minus 0.3, 0.6 plus 0.3 multiplied by G. G should be taken as not given in the question. So G equal to 9.8, let's take it. Okay. So this will come out to be equal to 9.8 by 3 meter per second square. Now coming to first part of the question. It is asking find the distance traveled by the first block in the first 2 seconds. So that's very easy. So part A of the question, distance traveled will be equal to AT squared by 2. Very easy. So 9.8 by 3 into T square, time is 2 seconds. So 2 square by 2. So when you solve this, you will get this to be equal to roughly 6.5 meter per second square. Coming to part B, find the tension in the string. Okay. So tension can be found using this equation T equal to M1G plus M1A. Okay. So for the part B, T equal to M1G plus M1A. M1 is how much? 0.3 kilogram. So this is 0.3 kilogram and G plus A. G is 9.8. A is how much? 9.8 by 3. Okay. So you'll get this to be equal to 0.3 into 9.8 into 4 by 3. Okay. So the tension will come out to be equal to 3.92 Newton. Now coming to part C of the question, find the force exerted by the clamp on the pulley. So that's very easy. We just need to draw the FBD of the clamp and the pulley. Okay. So let's draw the pulley. This is your pulley. Okay. So the clamp is applying a force F upwards while the two strings are applying a force downwards from either direction. There's a single string in fact is applying force equal to tension downwards from both the sides. So we are solving for part C. So since pulley is massless, we consider F minus 2t equal to mass of pulley into acceleration, and acceleration of the pulley and mass of pulley both are 0. So we get F equal to 2t. So F will be equal to 7.84 Newton. This is the answer.